After the spread of the coronavirus crisis and the requirements of individual quarantine in the whole world, it was the first time in Dubai to lock down all the facilities, and the hotel sector was one of the most affected because of closing tourism. Such a problem led to needing emergency hospitality buildings to save human health and protect the life quality inside the United Arab Emirates. In this video presentation, we have 5 steps: introduction, site analysis, concept and design, IES analysis, and finally the conclusion. Let's start with our introduction. The United Arab Emirates is the second highest country in energy consumption and electricity in comparison with the rest of the GCC countries. These statistics consider as a sign to focus on the energy sector, especially in hotels, due to the high energy consumption. The selected site is located in Al Garhoud district, which considers as an active zone in all Dubai. Because of the need to be near to the airport and hospitals, this location very good to help people who suffer from quarantine or closing airlines. The idea of post-pandemic hotel should respect the safety distances between people and the awareness of the implementation of minimal staff interaction with guests and patients, and people's requirements in terms of internal quarantine functions to create an excellent room with a high level of comfortability and availability of doing activities inside the single room. The activity space proposed to be a healthy and safe alternative of outdoor activity spaces. Due to the need to ensure safety in the post-pandemic world, hotels need to incorporate significant changes to secure protection for quarantined people. As proposed, many activities can be applied in this activity space. The concept of the hotel design starting from designing a single room and multiple the room units by overlapped in 2 directions to get the initial concept of rooms mass and elevations. The entrance and lobby area in the ground floor illustrate the orange space only for enter for new guests and patients, while the green space for exit only for the recovered people after quarantine, and they can only exit from the courtyard area to ensure the safety. The best case design is a modern design with a high percentage of glazing, which need to study in terms of our designing role. The climate of Dubai determines a hot to humid climate. The needed strategies are passive cooling to maximize the ventilation and air flowing, besides to reduce the energy consumption and enhance the thermal comfort levels in the quarantine rooms. We refined the best case design using Safati Green Building Code and applying the passive measures to get the passive case design. Firstly, by finding the optimum orientation in 45 degrees. Secondly, by elevating one mass up for ventilation and adding water features under the elevated mass to work as evaporative cooling strategy. Thirdly, by designing green walls instead of corridors glazing to reduce the solar gain and maintain the temperatures. And finally, by adding green roofs to work as insulation layers. After many trials in terms of building orientation, we got the lowest energy in 45-degree north oriented. Then took the results with adding the passive measures to calculate the optimum passive case before applying the strategies. For the passive case, we selected the material depending on SAFAT specifications, with U value about 0.52 for external walls, which use in the bronze and silver SAFA, while the U value of green roof layers reached less than 3, which can consider as golden or platinum SAFA. After elevating one mass up, the air velocity and circulation became more effective with the courtyard, especially the elevated mass located in northeast and northwest sides. The wind tower concept or wind catcher is about collecting the air under high pressure to release it and distribute it from the high pressure zones to low pressure zones to improve the natural ventilation inside the building. Selecting the wind tower location depends on wind direction, especially in winter months, due to closing the AC system. The air quality after implementing the wind tower strategy will be better in the winter months because of natural ventilation in corridors. The air temperature will be more comfortable due to continuous exchanging the air. Focusing on level 7 to study the direct effect of wind tower on cooling loads and energy. The reductions before applying the strategy were very high due to closing the AC in winter months. With the optimum building orientation, all the glass rooms will be in northeast and northwest facade to protect the glass activity rooms from south solar gain. By applying the shading devices in northeast and northwest on all glazing rooms will help to reduce heat gain. The northeast shadings will protect the northeast glass rooms, mainly in morning times, while the northwest shadings will protect the northwest glass rooms in afternoon times. Focusing on level 7 to study the direct effect of shadings on cooling loads and energy. After applying the shading strategy in summer months, we'll compare the initial passive case with the improved passive case to get reduction ratios approximately 16, 18, and 22. The double skin facade concept. In hot climate, the cavity can be vented outside the building to mitigate solar gain and decrease the cooling load. Excess heat is drained through a process known as the chimney effect, where differences in air density create a circular motion that causes warmer air to escape. As the temperature in the cavity rises, it is pushed out, bringing a slight breeze to the surroundings while isolating against heat gain. In the winter scenario, the AC will be closed in the winter months, January, February, November, and December. Firstly, the wind tower will be opened to vent the corridors through the internal windows. Secondly, the shadings will be closed in the winter months. And finally, the double skin facade will be opened to vent the rooms through the internal window, while the external openings in double skin facade will be fully open all the year. According to our analysis and trials, the best scenario in winter months for passive cooling and to save energy will be by fully open all the wind tower windows and fully open the internal window of double skin facade to give us better results. According to our analysis and trials, the best scenario in summer months for passive cooling and reducing the energy consumption will be by close the wind tower internal windows and open the AC from March to October, and the shading devices will be opened. Besides the third strategy, double skin facade, the internal window will be closed and the air will exchange through the external openings and the gap between the double glazing layers. The cavity to act as a chimney and will reduce the solar gain inside the rooms. In the conclusion, we noticed that the double skin facade strategy was the most effective strategy, especially in summer months, in terms of reducing the solar gain and cooling loads, which affected directly on energy savings. Finally, the initial reduction between base case and initial passive case, it was very good in terms of applying the passive measures and maximize the benefits of climate conditions and designing elements. To take in consideration the cost effectiveness, it will be better to focus on one strategy implementation.